In the world of engineering, bridges mean steel. Tons and tons of steel. For thousands of years, it's been the gold standard in strength. The power needed to suspend massive girders and bolster concrete.
The measurement of those points.
But now, the University of Miami's College of Engineering is completing work on a bridge to the future.
We're rolling.
A 70-foot-long span, erected, engineered, and standing today without a drop of steel. No steel means no corrosion. It's the first of its kind and appropriately called the Innovation Bridge.
We have replaced conventional reinforcement, what we call carbon steel or black steel, with composite materials. We are using different types of fibers. We use glass fibers, we use carbon fibers, we use basalt fibers. The other great innovation is in the fact that also the substructure, the part of the bridge that is underground or in contact with the ground, is also made with these materials.
Under the direction of Professor Antonio Nanni and Dr. Guillermo Clare, engineering students and other COE faculty partnered with local engineers, contractors, and suppliers to see the historic experiment go from lab to life. When complete, the Innovation Bridge will be quantifiable proof that UM's College of Engineering is on the cusp of revolutionizing how we build.
Is that we're trying to couple two technologies, non-corrosive reinforcement bars with a sustainable and resilient concrete. And what happens typically with rebar when you mix it in a saltwater environment, it's rust. And actually, the Boston Globe recently said that the most damaging parameter for global sea level rise is going to be corrosion, the corrosion in the foundations of all buildings.
As corrosion around steel rebar grows, it eventually cracks the concrete in bridges and foundations, creating massive maintenance costs and even failure. In the lab, young UM engineers test the endurance of FRPs, shorthand for fiber reinforced polymers, the steel substitutes used to support the new bridge. The FRPs can be molded into any shape and can arrive pre-assembled from the factory.
It's very, very light. If this was steel, I wouldn't be able to lift it. This is 1/4 of the weight of steel. Very easy to handle. The 40-foot long pieces came directly from the factory. We are really using materials of the future, techniques of the future.
This is cosmetic.
The advantages to building with composites are extensive. FRPs are stronger than steel, some by as much as 50%. They weigh just 1/4 the weight of steel. When mass-produced costs the same as steel manufacture, and no metal means no corrosion and no costly maintenance.
It's very lightweight for what it does. So handling it, trucking it, shipping it was user-friendly to start with. The installation of it was simple. We installed it using nylon tie wraps to eliminate any wire, any steel products in it at all. The potential for the future I see is going to be that it's going to eliminate the corrosion problems.
When finished, UM's Innovation Bridge will provide a much-needed link from the campus to the athletic fields. It will also continue as a living lab for research, testing, and teaching. Sensors were installed throughout to monitor and measure success and any challenges that may arise for years to come.
Many communities throughout the world are facing challenges with sustainability. Their bridges are falling apart. So we invite these communities to come to us. We would love to partner with them to help them solve their problem. We invite the industry to join us. And so together, I think we can solve many of the challenges in sustainability.
For UM's engineering students, the bridge is a chance to be a part of history.
I am proud to be part of this project because this bridge will serve the campus for decades and it will continue being a research lab for future students.
As a student in transportation engineering, for me it was a very good opportunity to work on these new kinds of technology and materials used for this bridge.
Let's do it as fast as we can.
And the Innovation Bridge is just the beginning. The University of Miami has partnered with the Florida Department of Transportation to bring its game-changing technology to a new vehicular bridge north of Tampa, continuing UM's mission to always bridge to the future.
I can't wait to start on the next bridge.